Welcome, everyone. My name's Sean with the Chester Paul Company, and we are here with another Chester Paul podcast conversation with industry experts. Today, joining us is Jake Moen with DuPont. Good morning.
Hey, good morning, Sean. Thanks for having me.
Absolutely. Jake is with DuPont, industry legend, gold star manufacturer of membranes and resin technology. And today we'll have a chat mostly around the membrane FilmTec division of DuPont, formerly a Dow company. But a little bit about Jake, a little bit that I know. He's a chemist by trade, University of Concordia.
Yep.
Yeah. Out of Minneapolis or Minnesota?
Moorhead, Minnesota.
Moorhead, Minnesota.
Yeah.
And we chatted before here. You will find him on the ice in a hut fishing every now and then. But married to a doctor, so lots of brains in the house. 3 children, huh?
That's right. I got a 9, 6, and a 3-year-old back home.
That's a fast-moving household.
Yeah, it keeps us busy, but yeah, we enjoy it.
Awesome. What probably some pretty neat science projects going on in your house. You ever done any water treatment science projects yet?
Yeah, a lot of my experiments are around water, as you can guess. Kids aren't as excited. They want things to blow up and turn funny colors and burn the house down, but we haven't done those ones yet.
We can probably blow up some water molecules or something one day, but cool. So Chester Paul's been a fan and has done a lot around bringing FilmTec to the Water Quality Association and the drinking water side or water consuming side, if it's in a home or in a light commercial application, with FilmTec for over 20 years, going back to the late 90s, I believe. And we've been working with Jake just recently over the past few years on the newer projects that FilmTec has that we'll get to in a little bit. But I think first we should probably hear. We focus, like I said, on residential primarily at Chester Paul, but DuPont and FilmTec is a much bigger, has much bigger eyes than we do here. Can you tell us, like, some of your customers and some of the applications that DuPont plays in?
Yeah. DuPont, our DuPont Water Solutions is the group I'm in as part of DuPont, and I mean we are a global company, so I would say we range from all customer sites, from municipalities to power plants to bioprocessing, chem processing.
So on the municipal, I was thinking of this just yesterday. They were showing a new reservoir, which is pretty rare here in California that we actually have a new reservoir. But and they were doing a schematic of the treatment that's going to come out of that, and there wasn't reverse osmosis. What percentage, or how often do you think they're using reverse osmosis actually in a municipality treatment?
I don't know the percentage, but it's becoming more and more common. I would say it's a tried and true technology that's been around. So there's still some hurdles with it, just the cost and it's still considered advanced technology, but to us it's pretty standard technology nowadays. But there's still municipalities that maybe are a little scared of trying something new with the new technology, but I would say in all new projects, it's definitely an option, probably one of the first options that comes up.
Yeah, I can see it being probably one of the more reliable to wrap your arms around a lot of problems with one type of treatment versus using ozone and having to couple together 10 different types of technology. Membranes do a lot more than a lot of other treatment options, which we'll probably get into more of that later. But so from big municipalities and wastewater even down to...
That's right. So talking just residential, I mean, we go down to the under the sink models to car washes to any coffee shops, McDonald's, you name it. Right. They all have some sort of treatment in them. So.
Right. And then the other half of the business unit is all resin. So from a softening resin to all sorts of specialty type resin.
That's correct. So the biggest portion of our company is the reverse osmosis, but then we have the resin, which you said is kind of in the same vast variety of applications. So the residential would see it as a home softener type unit. Right.
Yeah, and then anything you get into lab water, and you're using different resins and different.
There's a lot of trace contaminant applications out there, and
you guys use membranes to separate maple syrup and dairy and all sorts of liquids, right? Like where you're actually. On the maple syrup, if I'm not mistaken, they're actually it's reversed. What we would consider the concentrate or the wastewater is actually becomes the product on the maple syrup side of things.
That's right. Yeah. So you can use the water filter. Yeah, it's kind of using it backwards, where you're keeping the concentrate and you're throwing away the clean permeate.
The clean permeate. You're just removing the water from the syrup, right? Yeah. Right. Okay. Cool.
Same with the dairy. Same with whey processing cheese. They all use the same kind of concentration model.
Okay. Yeah, that makes sense. Yeah. Removing the water, from the from the product that you're actually going to bring to market. Yeah. Cool. Why don't you try to spend, and we forgive you now, or forgive us now, because we can get into the weeds here a little bit, but try to explain to us how a membrane works. I mean, there's I don't know, this is a residential, obviously, but all the same type of construction from this to an 8-inch, really, more or less. The same components, I should say.
Same components, yep. Well, it all, to me, starts with the membrane, right? So that's
which is the
heart
sheet, right? So
that's the membrane sheet. That's what's actually doing the filtering inside. Yep.
And how's that made? That's like a piece of. In the old days, we used to have a CTA, which is a cellulose.
Yep.
Yeah. This is a thin film composite, right? We call it a TFC membrane.
This goes all the way back to John Cadott back in the mid-'70s, where he was the first to patent the thin film composite.
So that's FilmTec started in the mid-'70s with a thin film composite membrane.
Correct, yep.
And it's a similar, nowhere near performance-wise, but a similar type sheet that is used today, right?
That's right. Yeah, we still kind of use the same nomenclature. The FT30 membrane is, but as you can imagine, we've made a lot of advancements since the mid-'70s. But the same concept, using the same,
it's no different than it's the engine that drives the performance, just like it is an engine in a car.
Right.
But we've come a long way from the Model T.
That's right. Yeah. And a big part of that was in the mid-'80s was when Dow took over FilmTec, purchased FilmTec, and Dow had the resources, right? So they had the R&D engine, and they had, the manpower to throw at it to really kick FilmTec into gear. Yeah.
And FilmTec, as I think anybody in the water treatment or even wastewater, anybody in the water treatment world knows who FilmTec is and is aware of the products they make. So now the water comes into the vessel. And the brine seal forces it, if I may.
Yes, please.
my pre-K vocabulary on how a membrane works here. So the water comes into the vessel, it hits the brine seal, forces it all through the membrane sheet. Correct?
Yep. So the water would actually be traveling across the feed screen, we call it. So it's a mesh open layer that the water can flow through. It's not a clean path. It's kind of turbulent path in there.
Right. So you lay membrane, and then you also lay like this netting, which is what you're describing, right?
Exactly.
Like over it, and then you wrap several layers of that.
Yep.
And so the water comes in and it's bouncing around as it's spiraling through the membrane here, right? And then it's forcing the concentrate or the contaminants in the water, the dirty water.
That's right.
Toward the outside of the membrane, which is along here, right?
Yep.
And then the product water comes out the core?
Yep. So the water, once it's able to pass through the membrane, we call it the permeate carrier, or it'd be what's inside the membrane envelope that we make.
Okay.
Once it reaches in that, then it's the pure water, and then it just has to spiral, find its way to the permeate tube, and then comes out as pure water out the permeate tube.
Right. So and then it's separating and sending the dirty and contaminated, the concentrate water at that point to drain.
That's right. It's not a dead end process. There's other applications, like mainly ultrafiltration, that can run as a dead end, but this is a pass through. So while you're making water, you're also having a concentrate stream constantly flushing, keeping the membrane clean.
Yeah, that's what I was going to say. It works as a secondary process of keeping the membrane clean too, descaling, pulling out some of that calcium, magnesium off of the sheet.
Correct.
Yep. Cool. Obviously, we talked about it being made or invented in the 70s and how long it's come. So this membrane technology is like a by far favorite of mine. And Chester Paul Company, we focus on filtration and reverse osmosis. Membranes are obviously not a flavor, or membrane element technology is not a flavor of the month type product. Like you were talking about with municipalities earlier, it's definitely proven. And there's not in my mind, and we have to be more specific when we put it in a product as to what its performance capabilities can be. But since it's not in a product and we're not talking about a certified finished good, a membrane alone does a whole lot when it comes to water treatment. And if we break this down to a conversation around what it can do underneath a sink for a consumer, you're putting your arms around a massive amount of contaminants in the water. But before we probably talk about those, which I definitely want to, can you help us understand what this will do versus like mechanical or like a depth filter?
Yep.
Because a depth filter is going to pull out chunks, right? Like anything solid in the water.
Sure. Yeah, there's a filtration spectrum, right? We have all the way from we call them suspended solids. That's literally chunks in the water you're trying to remove.
Logs,
sticks. You got it.
Down to like a 5 micron or 1 micron particle, really. Right. Yeah. Okay.
So you kind of go suspended solids, then you start getting to some dissolved solids.
So how do contaminants end up in the water that are dissolved?
Well,
I think that's kind of the mystery, right? Like, because we don't actually see it. It's not cloudy water. Doesn't mean that there's dissolved stuff in it, right? I mean,
you can look at a glass of water and it might look clear.
Yeah.
But it could have, dissolved lead and arsenic and all these nasty things you probably don't want in your drinking water.
Right. Now, and how do those get into the water?
Well, I mean, I would say if you're using one of these, if you're on a well water, per se, perhaps that the area you're in the country, where there's lots of areas with different amounts of arsenic and just normal TDS, they just dissolve in.
So TDS for people.
So water is a very, it can dissolve solid rock as it sits down there. So
yeah, we say TDS a lot in the water industry.
Correct.
Just to be clear on that, that's a total dissolved solids that's accumulated in the water, and we typically read it in the parts per million, right?
Correct. And that's kind of a good first check just to see what kind of water it is that you have.
So that's like the accumulative of all the junk that's dissolved in the water. If it's just, like you said, rock or calcium or...
it could be just sodium chloride, and it could be just great water to drink. But your TDS is kind of an indicator, for what kind of water it is.
And so that all gets dissolved into the water just through the natural food, the water table, right? Like between rivers or VOC or TOC runoff from, if you're getting surface water and there's boats on a lake or whatever else, you're going to end up with contaminants, and it's still all dissolved in the water.
Yep.
Plus, there's naturally occurring, as we know, lead and arsenic just in groundwater.
Right.
And then a lot of those same municipalities that are cleaning water have old or deteriorating infrastructures.
Right.
There's obviously been some famous ones in Michigan and other places that that have been in the news, but this will remove, and that was a dissolved lead problem, right? In Flint?
Correct.
Okay,
yep.
yeah. So that was old infrastructure, changing of the chemistry of the water, which extracted lead from an old infrastructure, sending it downstream to the home.
Correct.
So the membrane technology does the heavy lifting, let's say, of all these heavy or dissolved solids, from heavy metals to VOC, TOC. Right. What else am I missing there?
Yeah, no, I mean, that's kind of where the membrane development has gone, where back in the 70s and 80s, we would kill for 90% recovery and 90% rejection of these, chemicals that we're talking about. Yeah. But now we're talking 99+% rejection of these. So
that's what I was going to say. The membrane market, it used to be considered expensive technology, and it used to be, we were at, like you said, 85, 90%. Now we're at 99, sometimes 99 point something percent rejection, and that's you're removing, and we're already counting in parts per million, sometimes parts per billion, and now when you're rejecting 99% of that content, it's really one of the most effective tools out there.
Yeah.
Meanwhile, the cost has stayed the same or come down. So this proven technology has come a long way. Like we said, it wasn't flavor of the month, but it continues to you guys continue to or DuPont for FilmTec continues to put resources in to drive the performance of these things.
Yeah, well, I've actually seen some of the first FilmTecs that came off the plant.
Oh, real cool. It was so you started in the chemistry lab there.
That's right. Yeah, so
making sheet, right?
That's right. But those first ones was duct tape and feed screen from Menards that they piece these things together. So
feed screen like for chickens.
That's right.
Oh, yeah. Awesome. I always. If you can make something out of duct tape, it's a solid product, right?
That's right. So just to think, I mean, that's where, Dow and DuPont, as big manufacturing-focused companies, have been just taking that to the next level, fully automated.
So I've seen the automated of these things, and it's amazing. There's a few guys watching computer screens, and the sheet that we were talking about earlier, the heart of the membrane, comes from the sky, basically. It comes from the rafters of the plant down into this machine, and there's lasers all over the place checking tolerances, and from start to finish, this is built by automation. Which adds what value? I mean, it adds tremendous value.
Tremendous, yeah. It's really just in the consistency, the quality, just having, automated glue lines. There's a lot of...
So a glue line, I mean, that's like how many square foot of membrane you get, right? Like that's just make sure you get what you're buying.
Exactly.
The solid analogy, I guess, for that is... if you bought a home and you thought you bought an acre, and it turns out that, your neighbor's fence is 40 feet in on each side, and you only bought, 2/3 of an acre or whatever. That's what happens underneath when you pull back the cover on a imitation or less expensive or, imported membrane that isn't rolled with quality. Your glue lines are laser solid and repeated in every single membrane, where the others are done by hand.
Exactly.
On a workbench.
Right.
They're still using chicken feed screen and Elmer's glue, right? and there's also your consistency with automation comes down to nobody's touched it. I mean, I've unrolled these and actually seen fingerprints on the sheet before, so it's
no, there's no interaction when you make these. They just load the raw materials and
So the residential market, obviously I'm really familiar with. And then when we get into helping folks with 4-inch or let's call it 2,000 plus gallon a day type systems, probably between 2 and 10,000 is kind of where Chester Paul plays.
Yep.
Obviously, you guys then get into, I don't know, what's the biggest system you've heard of being involved with? Any idea?
Me involved in? Not too much, because those big giant systems are usually in the Middle East and China and those ones, but they're in the thousands of 8-inch seawater RO.
So millions of gallons a day.
Desal plants.
Yeah, millions of
quite massive.
Yeah.
I mean, even here in Orange County and lots of plants here uses us, and they're big plants.
Right. So, and those are 5,000 gallon a day elements or 8,000 gallon a day elements, and they're using thousands of them.
Correct.
So hundreds of thousands, if not millions of gallons a day of treated water.
It's no big deal to get a 20 million gallon per day plant.
Wow.
Yeah.
Cool.
They're big.
It's no big deal.
Yeah.
Yeah. We're happy, we are 50 gallon a day. No.
50 gallon a day. Yeah.
This is the scrap they cut off of those those other elements. So no, we got into kind of on the automated here, but I know that DuPont FilmTec offers a whole design program. What can you tell us some about the resources?
So that's what we have a Wave software now.
This replaces Rosa, right?
That's right.
Okay.
So Rosa is now retired. So all the old timers out there that are still using Rosa are...
Don't take offense, because I guess I'm an old timer too. Experienced.
There we go. Right. So so Rosa's been replaced with Wave, and has the same background, but a little more user-friendly interface. So
a consumer or an end user can sit and dump in all their contaminant levels.
Yep.
So they come in and say they've got X sodium, X calcium, X nitrate.
Exactly.
And then they talk about their pressure coming in and the amount of water coming in, right? The feed gallon per day or whatever.
You can do feed or what you need out of it.
Okay.
But then, Wave does a little better job giving some recommendations where Rosa would just give warnings, and you'd have to really kind of know what you were doing to overcome those warnings. So
give me the little red triangle or something.
Right.
Yeah, a little hazard sign.
You had to know whether it was a big deal or not. Where Wave kind of will say, this one you should probably tweak this a little to get those to go away. So.
And that's where you can really get into the efficiency of a system, right? Where you can dial in, and I guess we should probably hit on real quick, efficiency in an RO system is the percentage of waste or concentrate versus product.
Right. So in general, our products, when we test them at our warehouse, it's 15% recovery.
15%. So, okay.
Which now if someone hears 15% recovery, it doesn't sound all that impressive, right?
Yeah.
And so you can't design a giant seawater plant at 15% recovery. Right. So that's why we stage elements in a vessel. So each element does a certain percentage. So maybe by the time you're done with the whole system, you put a multi-stage system together, then you can get upwards of 80+% recovery.
Yeah, they're getting close. I know I've seen some presentations from DuPont on almost zero.
That's right.
Zero concentrate.
We've coined our term as MLD, minimal liquid discharge.
Minimal liquid discharge.
That's right. Right. So there's ZLD, which people have probably heard of. That's the zero liquid, but that
it'll never be
from
zero.
Minimal to zero is a challenge. So, but minimal liquid discharge is achievable with our products. Yeah.
Okay, and that's really where we're almost a closed loop system. You might be in fractions of where even in a closed loop system, you're probably still using a similar amount just to clean a surface or to do something else. It's just not calculated into that zero.
Right.
So, I mean, it's talk about coming a long way. So you guys are involved in sustainability. I mean, it's obviously a buzzword that
Right.
is in the media.
It's a buzzword, but it's it's very important to our company. We like to think of it as a water optimized world.
A water optimized world.
Right.
I like that.
Because I would say the news media likes to say water scarcity and like doomsday around water, where we like to say more let's work on water security. There's plenty of water out there, right? It's just not all in usable form.
Right.
Right. So it just takes the right product, the right technology at the right application to...
You're absolutely right. I mean, I live in California, and we sit and talk about water scarcity and as a precious resource. And yes, it's a precious resource, but we have technology and the lack of the responsible parties, I guess, government, to invest in these technologies, or even just digging new holes in the ground and creating reservoirs and whatever else.
Right.
We haven't done that. So now we have water scarcity, where we could be in much more of a water abundance type situation.
Yeah. So we like, right now we've partnered with some water charities. In the U.S. as a whole, we're better off than a lot of the parts in the world, right? So, but there's still, I think it's 1 in 10 live without water security, or drinking unsafe water. And it's upwards of 800,000 people die every year from waterborne
illnesses.
Yeah.
Wow.
So it's not like that's something you read in a history book. It's like happening today, right?
No, that puts a lot of perspective on. I don't know what I know the numbers of in North America, the numbers of heart disease and cancer aren't far from that number. So when you talk about 800,000, almost 1 million people dying from a waterborne illness, it's
right. And so that's where we're at this point now, where we have the technology, right? It just takes some investment, some creative thinking, some go-getters to just work on solving this problem. So
well, the good news is we have the answers. It's funny, part of the Pacific Water Quality Association that myself and Chester Paul have been part of for a long time, and then the Water Quality Association, we're always engaged with either Sacramento in the case of California, or DC in the case of the feds.
Yeah.
And there's been a lot of programs on delivering water to disadvantaged communities, and in California there's the Safer Water, which is now, I believe, called something different, but they're trying to allocate some federal and statewide resources to deliver quality water to disadvantaged communities.
Yeah.
And from my perspective, or even the associations, from the member perspective, we can deliver clean, safe drinking water on Friday afternoon. Where if we're going to wait for the municipalities to do it, it's going to be billions of dollars, and 20 years later, where we can install a point of use or a point of entry system, and tomorrow morning you've got great potable quality drinking water, probably better than the community down the road that passes its municipality's standards. So it's you're absolutely right. It's just the technology is far beyond what the regulations require.
That's right.
So it's funny because we've talking about efficiency. There's new momentum in the drinking water side of things from a group called WaterSense, which is they're the guys that are the folks that have put all the regulations on our toilets and our shower heads that a lot of us curse at, but at the end of the day do conserve water, and they're looking to do a standard for drinking water for states in the West like California, Arizona, Nevada. It would be a national standard, but to tune up the efficiency rating on what manufacturers that use these products for drinking water, they would have to basically retune their system so it's at a much higher efficiency standard. Basically, we would be wasting less water to make quality water. Right. And to me, it's kind of a no-brainer because, like I said, I've been working with FilmTec for years and years, and they've had the technology to do so. So it's finally to see some sort of, I mean, it's EPA, kind of Big Brother-ish, but it's
right.
At least government is catching up to what technology is available, which will force and encourage, I guess, participating manufacturers to, right. We'll have more influence on what these regulations are, because it's not that hard to achieve like it used to be.
Right. And let's be honest, these 1812 and specific elements, there's a wide variety of options to choose from.
Absolutely.
It's a crowded market with lots of different quality, I should say, products out there. So you can pretty much get from the high quality down to maybe you're not getting so much quality.
So yeah, you can choose a DuPont or FilmTec, which for anybody who's been around would consider it the gold standard, right? That's been the leader.
Yep.
And honestly, I'm biased, but I think I'm still being pretty honest when I say always setting the bar higher. Always pushing the rejection and the life and everything else of these elements way beyond what the competition's doing. I mean, the competition can sometimes focus on just buying the same color blue tape, so they're trying to copy the look of the element without giving paying any attention to the quality of the actual product.
Well, I wanted to mention it just because you mentioned there's some new regulations coming out, and that's what we would welcome, because if you just look at a data sheet, someone can make a product and put a flow and rejection on a data sheet, but you don't really know 6 months from now, is that product going to hold up?
Yeah.
Is it going to actually do what it says on the data sheet?
Right. Well, and a lot of times, just to educate people on recovery versus efficiency, recovery is when you're running with an open spigot. So we can say we're being efficient, and it's just running both to product and concentrate. So it's just running to drain and running. It's done in a lab. It's run open spigot. You would never really use it like that in a real world underneath your sink.
Right.
Where efficiency is where we put our little tank next to it and everything else. Now you have back pressure. It's being turned on and off as Mrs. Jones gets a cup of coffee, gets a cup of water, or makes a pot of coffee. And that's when it gets a little bit more challenging to get these efficiencies.
Yeah.
But I've tested membranes and quite honestly hammered them, bringing them back to where I needed to make. My test parameters, and forgive me, I'm not a chemist. Remember pre-K chemistry. We would try to produce 4 gallons of product water or drinking water, and keep our concentrator waste at a gallon. So I mean, we were trying to run at 75% efficiency, and we would test that over like a 45 to 60 day period, and we were able to maintain our rejection levels, and our flow rate would start to tend to drop a tiny bit, but it was nuanced compared to competitors, where their curve would look like a upside down L. It just would fall off the place, and that's where people aren't checking. Yeah. If a dealer or somebody's coming into the house and just checking TDS, you still might be rejecting 90+%, but the flow rate of that element is nowhere near what it was, so everything's probably running into drain.
Yep.
And that'll happen with everybody's element, but it's going to happen a lot faster on the less expensive, or to be nice, I guess, the elements that have less resources applied toward newer technology.
Exactly.
Yeah. So, and is this trends? I mean, it started in China and India. I mean, you guys are global, so you're obviously going after demand in these places of the world is, I mean, 4 times the population in North America.
Yeah.
And the water quality is horrible, right? Like,
right. It's much worse.
Much worse. Yeah. It's a nice way to say that. Where we would look at a 500 or 600 parts per million in North America as being challenging. They're constantly seeing 2,000. Yeah, 2,000.
Yeah.
And I've watched personally the DuPont range of products where now you're testing on 60, 70 psi, 80 psi feed pressure, maybe 100 psi feed pressure at 3,000 parts per million.
Right.
Where that was never done. Even 5 years ago, you would never have test results published on this type of quality of water. Which translates to us as we can just be even that much more efficient because we're running with much cleaner water here.
Right.
So.
Yeah, I think that's going to be a trend, obviously, going forward. It's all going to be about efficiency, durability. And
it's no different than most technology when you look at the history of a car or the history of any sort of technology. How do we make it more global, environmentally sustainable, and while maintaining the performance level that the consumer demands? We have more and more emerging contaminants in our water, so you're always going to be challenged with pulling out, more of the garbage in the water. I mean, it's amazing now. We're even seeing hormones in our drinking water systems, and these are going to be, again, it's a dissolved solid, right? So you're removing it all.
Yep.
What? I mean, we probably get close to wrap up, but why would I want to use DuPont if you can help educate myself and reinforce to the folks at home here?
Yeah, I would say first off, it's just the trust in our brand and in our products. We've been doing this a long time.
Yeah.
We've came a long ways, and we are still making the same high quality product that we have. It's been a good, FilmTec's been around, so.
I can tell you, man, it's based in Minnesota, Minneapolis.
That's right.
It's where you came from yesterday, right?
Yeah, I appreciate the trip out to California here to get out of Minnesota for a few days.
Usually we get all of our visitors in the middle of winter, but welcome to usually sunny California. But great people too. I mean, all the research is you're doing research now globally because you've got different markets. But corporate is still in Minneapolis.
That's still our headquarters is in Minneapolis. We still have our R&D center is there. So that's where most of that, everything FilmTec comes out of Minneapolis.
All right.
Yeah, and then the other one is just like being able to contact us and finding resources online. We have a whole technical group. So it's really the resources behind the product as well, right? We feel good about the product, but if there are any questions, we have a very large resource pool to pull from. So
yeah, the amount of resources that DuPont is always continuing to reinvest has always impressed me.
Yeah.
Now, I mean, obviously the authorized distribution network and dealers of the product can answer most of the consumer's question, but if somebody wanted to get into the nitty-gritty of how it's made or really how it should be working with their water, there are resources on DuPont's site.
Yeah, and even for the consumer, you can go on our website. We have a thing called Water Academy. They're pretty cool. You can look up whatever you're interested in, which technologies, and watch their usually 60-minute. You can do them live, so you can ask questions to the presenters, or you can watch recorded versions online. But then there's lots of resources, just brochures and white papers on, exactly what we're talking about, pushing the envelope with the elements or new applications if you're interested in.
Right.
You can pretty much find what you want on there.
Down to that, you're putting a QR code on.
There is a QR code.
Yeah.
Yep. There's a DuPont Water app now. If you download the app, and you can just scan your QR code, and it will tell you the serial number, make sure everything matches. It's an authentic, made from FilmTec product, and pull up the data sheet and other info you need on it. Yeah.
Fantastic. Well, cool. So I think we gave a kind of a quick snapshot into DuPont, where they are today and what they're continuing to do. And I know we stayed on the residential, light commercial, but that's kind of the bubble that...
I know, it's hard for me to not, want to go down all these other new, cool, innovative products.
Yeah.
But if you have questions, we can go over those. Yeah.
Yeah, for sure. And we'll get you back here and get into... maybe we'll get somebody to join us that can keep up with you on the big stuff. I live in a pretty a small world when it comes to DuPont, but the technology it's the same technology you're using in 8-inch desalination plants down to a residential.
That's right.
And your capabilities are just massive. So it's definitely it's fun to be associated with a industry leader.
Well, we've sure appreciated the partnership with Chester Paul as well. So
thank you, my friend. Well, we'll wrap this for today. Thanks for coming, and hope you guys learned something on elements. And if you have any questions, don't hesitate to reach out to us at Chester Paul. I can get you in touch with Jake here or anybody at DuPont. And have a great day.